All right, so section 2.1 starts on page 48. So it's on page 48. So if I give you something like this, if I said, describe the transformations of f of x equals x squared to the new one, g of x equals parentheses x plus 4 squared minus 1. And so if I asked you to describe the transformations that take place, so I gave you the first one's f, the second one's g. So from f to g, can you describe what changed? Can you describe the transformations? I'll give you 30 seconds. If you're sitting by yourself, just kind of lean over maybe and work with somebody, but come up with in your groups the transformations that take place. All right. Peyton, in your group, what's one of the transformations you guys came up with?
Left 4.
Okay, I just said one of them. You can stop. So left 4. How did you guys know it was left 4? Plus 4 after the x? On the outside of the parentheses or inside? Inside the parentheses, and adding 4 means left 4. Is everybody okay with that? Did your groups have that? Okay. Teague, what's the other one? Down 1. How'd you know? It's on the outside of the parentheses, and I can't write the word down. Oh my God, I should just stop. Okay, so I got those two pieces. Was there anything else that we missed, or is that it? Is that it? Okay, now, they're going to ask you to describe the transformations that took place, then graph each of them. Can I ask you what's the difference between this and chapter 1? Chapter 1, it said graph the function and its parent, describe the transformations that took place. This one says describe the transformations that took place, then sketch each graph. What's different? Nothing. It's the same, except for this purpose. And I heard one group talking about what type of parent it was, and they said it was quadratic. The difference between chapter 1 and chapter 2, chapter 1, it was introducing you to all the parents, or some of the parents, that is. The constant, the linear, the quadratic, and the absolute value. Chapter 2 is only going to have quadratics. It will not have any other parent for you. So it's only the quadratics. So when I say that, what types of graphs do quadratics look like? The U. So if I were to sketch both of them, I'm going to put the parent in black. So if that's my parent, the new one is in blue. According to what you guys told me, left 4, 1, 2, 3, 4, and down 1, right here. So what I'm moving, or what I moved for this one, was the bottom of the bowl. The bottom of the bowl right there is at 0, 0 on the parent. You guys told me to go left 4 and down 1. That's where the new bottom of the bowl should be, over here. Now, some other terminology that's involved in this, and it will ask you to do this. It will also ask you what they call a vertex. A vertex is the bottom of the bowl, or top of it if you have it flipped over. Okay? What ordered pair was the new bottom at?
4,
Negative 4,
yeah.
negative 1. Because you went left 4, down 1. That's known as a vertex. So I'm gonna put a capital V by it so that you know it's a vertex. Vertex again just means where is the bottom or where is the top if it's flipped over. They will ask you on 2 questions, what is the vertex? Okay, what do you guys think of that so far though? Do you guys remember the up and down, left and right? Okay. How about if I give you this one more time? Do you guys still have this? Plus or minus, squared, plus or minus. Now this time I did put a square up there. Do you notice that? And then the last time I didn't? Because I said it could have it up there, but now this one for sure, this whole chapter is just going to have a 2 up there. Nothing else. Promise. What's a negative on the outside do? Reflection over the x-axis. What that physically means for us on our graphs, instead of opening up, it's going to open down. Okay? What about this hole right there? I'm multiplying the outside. What does that do?
Stretch or shrink vertically.
It vertically stretches if that number is bigger than 1, and shrinks if that number is between 0 and 1. So if there's a times 2 on the outside, that would be a vertical stretch by 2, meaning your graph should be skinnier. And if there's a half on the outside, for instance, that would be a vertical shrink by a half, which means it should get wider. Some people's graphs, they were saying it was a vertical stretch, and they were drawing the same one that was there. If it's supposed to be narrower, make it narrower. What does a negative on the inside do?
Reflects in the y-axis.
Reflection in the y-axis. So here's what that does. Again, remember, instead of going up like this, it would flip over this way. Would you even really notice a difference? No. But it still would reflect over the y-axis. What's a number multiplied to the x on the inside do?
Horizontal stretch or shrink.
It's a horizontal stretch or shrink. Stretch if that number is between 0 and 1. Shrink if it's greater than 1. The other key piece to that is if there's a number there and you're pulling it out, you write the reciprocal. And if it's a number that you're supposed to put it in, you also put it in as the reciprocal. So if I say it at a vertical shrink of 2, or stretch of 2 or whatever it is, then that way when it goes in there, you put it in as 1/2. Okay?
You mean horizontal?
Horizontal, right? I say vertical?
Yeah.
Okay, yeah, horizontal. What does the number in this spot do?
Left or right?
Positive moves it left, negative moves it right. And what's the number in this last spot do? Positive moves it up, negative moves it down. Now, those are all the pieces, and realistically, that's nothing new from chapter 1. Everything about this is the same. The only difference is, instead of having all 3 parents at your disposal, you're only going to focus on the one. We're only going to focus on quadratics for this whole chapter. Okay? What do you think so far? Okay? Now, what if I gave you something like this that said f of x was x squared, and g of x is equal to negative 1/2 x squared. So as you're writing it out, be thinking about it. And then in your groups, come up with the transformations. I want to know the transformations first, then we'll go to graphing it. But in your groups, talk about what the transformations are. All right, so, Cutter, what's one of them that you came up with?
Reflect.
All right, so this thing right here, this negative sign right there is a reflection. Now, Cutter, here's the next part. Is it a reflection over the x-axis or y-axis?
X.
X, good job. That particular thing is over the x-axis. Notice it's not in parentheses. Okay, so that means outside. So if you take a look at that template I just went through and talked about again, it's a negative first, well that's a reflection. Okay, Mackenzie, what was another one you guys came up with? Vertical shrink, did you say? By how much? Good job. Nice work. Okay, by the half. This half is not the same. Now, this morning, I had another group that did this. They said that it was just a vertical shrink by -1/2. It is a very common mistake to make that they put them together. Okay? The negative sign is its own, then the half is its own. So be careful that you're actually looking at two different ones, not rather than two. So, how do you draw them? So the first one, again, comes up in here and goes back out. The second one, you guys told me it was a reflection on the x-axis, which means instead of opening up, it should open down. And being a vertical shrink by 1/2, it means it should get narrower, wider, or stay the same? Wider. When it's a half like that, basically what it's saying is if I had 1 and you got a 1/2, you'd be smaller. Okay? So in order to do that, just draw one in here that gets wider. Okay? Or better yet, if I'm a parabola, and if I took half of the answer, like if I put 2 squared, what's 2 squared? 4 on the normal one, but if I'm half as big as 4, then I'm only at 2.
Yeah.
Okay, so that's what it means. Instead of going up 4, you'd only go up 2. You'd only go half the distance. So that's why it looks wider. Are you guys comfortable with that? 2/3 of your assignment is just doing that. That look familiar? Okay, good.
Have to graph the parent with it too. Okay.
Yeah, graph the parent with it. It's a good practice thing. Okay? All right, the next thing that they're going to say is they're going to say something like this. Let the graph G be a vertical stretch by 2, a reflection over the x-axis, followed by a translation 3 units down, and you're starting with f of x equals x squared. Have you heard ones like this before too? Yes. Okay, if you think back to it, where I gave you something and then I wanted you to plug in the information and see what happens, you've done that before. On the test, it was 11, 12, and 13. That's exactly what you had to do. So, go in steps. First thing that should happen is vertical stretch by 2. For it to be vertical, am I inside or outside? Outside, good. For a stretch, am I multiplying, adding, or subtracting? Multiplying. So you said I'm multiplying on the outside by 2. So realistically, the first thing should be 2x squared. Now notice, I put it on the outside, meaning if you wanted me to, I could have went like this. Would it make a difference? No. It just show it a little bit, maybe a little bit differently, but yes, you just get 2x squared. The next one. Oh, that's done. The next one, reflection in the x-axis. Where do you put a reflection in the x-axis? Huh? A negative sign in front of the 2, because remember it's on the outside of the grouping symbol. So realistically, you could have put this like that, and then put the negative inside there, or on the outside, I mean. You've taken care of that. So right now you have negative 2x squared. And the last one, how do you do 3 down? On the inside or outside? Outside. Minus 3. Have you accounted for all 3 pieces? Yeah. This isn't new. The only difference is I'm not giving you all the parents to deal with. I'm only giving you one. Realistically, I almost wonder if this shouldn't be taught first than the stuff we did in chapter 1. Okay? So, let me give you another one just because you haven't had that many of these type again. If I say a translation 3 units to the right and 2 units up, so these 2 have to happen first, followed by a reflection in the y-axis. And, oh, by the way, the function is f of x equals x squared minus 5x. It's not just x squared. It's something different. So it's a little bit more complicated than what you think. So the first thing that we need to look at is I got to go right 3 and then I got to go up 2. So dealing with the right 3 first. When I say to the right, Peyton, where do I put that? You can look at the template. It'll be there if you wrote it all down. Right means what? And if you have to, you can phone a friend. Otto, you gonna answer for him? Go ahead, see if it's right. Negative what? Good. Inside or outside? Inside. When you're putting it in there, you're going to put it into the inside. Now here's where the inside is at. And this is the part that's going to be more complicated for you guys today. How many x's are in the problem? 2. It's got to go into each of those pieces. Have you ever heard of a term called substitution before? Not necessarily in math, but just in normal everyday lives. Have you ever used substitution before? Taken something out and replaced it with something else? Go to a restaurant and ask them to substitute fries for something else. You've done it. Okay? Or in sports, which I know I usually equate that a lot to. But in sports, if the tennis team isn't performing well, he might take Peyton out and put in somebody in its place that will perform. Or in hockey, my goalie is not doing so well, I'm going to take him out and put in somebody else. Same thing. Volleyball, that's in volleyball's terminology, to sub in. Okay? So when I do this, when you said minus 3 on the inside, here's what needs to happen. I had an x here, x minus 3. And I had an x back here, x minus 3. So wherever there was an x, I have to replace it with what I need to sub in. And the sub in is what you guys told me by the minus 3 for the right 3. Is everybody comfortable with what I did?
But you'd still only go to the right 3.
Mm-hmm.
You wouldn't go 6.
Nope.
Okay.
I would not go 6. I would just, it's still right 3. It's just I have to put it in both things. Now what you need to do from here is you need to simplify this. Do you know what it means by the term simplify? What does simplify mean? Put like terms together, get everything as cleaned up as possible. In order to do that, on the first one, have you ever heard an acronym called FOIL? Yeah? My suggestion on the first one is I would write that out twice. And the reason why I would write it out twice is because it has a 2 there. And then FOIL it. What's x times x? X squared. What's x times negative 3? What's negative 3 times x? And what's negative 3 times negative 3? 9. Okay? Now I know that I have some more cleaning up to do, but I'm going to also multiply here because this also needs to be done. What's negative 5 times x? And what's negative 5 times negative 3? 15. Add like terms. X squared had no friends. What's negative 3x minus 5x? Negative 11x. Good. And then what's 9 plus 15?
What?
9 plus 15.
24.
24. Awesome.
Wait, where did you get the 11?
Negative 3 minus 3 is negative 6. Minus 5 would be negative 11 total.
Oh, okay.
Okay? So, I just took care of the right 3. Now I need to go up 2. Now officially, you put the whole thing in parentheses and add 2 to the outside and combine like terms. So what are you combining for this one? Just the 24 and the 2. What's 24 plus 2? 26. So right now I'm at x squared minus 11x plus 26. I've taken care of the up 2. Now it says a reflection in the y-axis. Is y on the inside or outside?
Inside.
Inside. Which means I take and put a negative x squared minus 11 times negative x plus 26. Now I want to talk about the middle one because the middle one's where people screw up. The 11 does not go inside of it. The 11 is on the outside of that x, so that stays on the outside. If you're outside, you stay outside. You can't come inside. Okay? So when you're putting in an x or a negative x, you got to put it inside, so you may have to make your own parentheses. Yes, Sid?
Okay, so where did you get the 2? Like you lost me.
What 2?
That.
Oh, the plus 2?
Yeah.
Up 2.
Okay, so on the next. Okay.
Yeah, so then that's why I put the plus 2 there. And now I'm off to the third one where I'm reflecting it over the y-axis.
Okay.
Okay? What is a negative x times negative x?
Negative x squared.
Try again.
Positive x. Oh.
Negative times a negative would be a positive. So it's a positive x squared. What's negative 11 times negative x? Plus 11x. And then 26 didn't have anything acting on it, so I get just 26. And that's my answer. Now, on this particular part, or this particular problem set, this is going to be what you have to do for this one, and there is only, there's only one of those on your assignment. Okay? This one's probably going to be the one that requires you to do the most work. All right? The other ones, the rest of your assignment, just so that you guys have an idea, it says describe the transformation, then graph each function. Can you guys handle that? The first little set is just shifting. Then they're going to ask you to match something, which means if you have a picture with numbers, you match which one should match to it. Right? Then 17 to 24 says describe the transformation and graph each function. The difference between 3 through 11 and 17 through 24, 3 and 11 are just shifting it left, right, up, and down. 17 to 24 is the reflection and stretching and shrinking pieces. Okay? Then on 27 to 30, it says describe the transformation of the graph of the parent quadratic function, identify the vertex. So, here's what they want you to do for that. If you look at number 27, it says f of x equals 3, x plus 2 squared plus 1. So first of all, you guys need to list out what are the transformations. So just by looking at it, Grace, do you know one? Left 2. So one of them is left 2. That's one of the transformations. That took care of this number right there. Emma, what's another transformation? Another one that Emma had was up 1, which is taking care of this transformation here. Is there another piece that we're missing? Cole? We also have a vertical stretch by 3. So you have answered now the describing the transformation piece. As far as the vertex piece goes, You guys told me to go left 2, so left means minus 2. And you told me to go up 1, which means plus 1. That's the vertex. So when they ask you for the new vertex, if you went left or right, up or down, then you just put them in there as ordered pairs. If you didn't move, then your vertex is still at 0, 0. Like if I stood right here and didn't move, my vertex would still be at 0, 0. But if I go left 2 and back 1, then I'm at -2, -1. Okay? Then 31 to 34 says write the rule. Okay, so that's where those big ones that you guys didn't really like. And then 35 to 40 is matching again. All right. So on page 52 to 53, 3 to 39, multiples of 3. So again, that means you start at number 3, then you go to 6, and then 9, and so on.